children, welcome to digital class. I am sure you all must be eagerly waiting to learn something new. Today you will be learning a concept which you have not come across in your previous classes. But before we start our today's lesson, let me ask you a question. Have you ever visited Salajung Museum? I am sure many of you have done. What did you see there? You might have witnessed a lot of artifacts, warfare, cutlery, carpets, clocks and many more. So, what can we say? We can call it a collection of many rare artifacts from all over the world by Nizam. Now, there are two images, image 1 and image 2. What can you say about image 1? You can call it as a collection of books. And if I ask you, what can you say about image 2? You can call it as a collection of closed figures, but to be more specific, we can call it as a set of polygons. Now, if you have observed, I have used the word set there. So, today your topic will be sets, its definition, how do we denote it, how do we represent it, its conversions. So, by the end of today's class, you will be able to understand the concept of sets, you will be able to write sets in different forms, you will be able to convert sets from one form to another. Now, before we go into knowing what is a set, let us actually know who introduced sets to us. So, going to the history of sets, the theory of sets was developed by German mathematician Georg Cantor, who survived from 1845 to 1918. He first encountered sets while working on problems on trigonometric series. Now, you all must be wondering, what is a set? Don't worry. So, first let us get along with the definition of it. To define a set, we can say a well defined collection of objects is called as a set, and in a set, each object of a set is called an element. In our daily life, you come across many examples which are called as sets, but we may not be familiar with them, like pack of cards and your vowels of the English alphabet, which are A, E, I, O and U. Now, let us learn the traits and properties of it. Now, each object of a set is called an element. So, whenever we are talking about a set, we name each object, we call it as an element, and elements of a set exhibit a common property. Now, elements of a set are enclosed in braces. Now, whenever we are denoting the elements, we have to put them in braces. A set is usually denoted by an uppercase alphabet. The elements of the set are essentially denoted by lowercase alphabets. That means, if a set consists of English alphabet, they are essentially written as lowercase alphabets. Let us take an example of a set A consisting of the vowels A, E, I, O, U. If you have observed, I have denoted the set A with a uppercase letter, that is a capital letter A, and the elements of the set A are essentially the smaller case letters. If we take the second example, which is the first 5 even numbers, they are 2, 4, 6, 8, 10. So, set B consists of the elements 2, 4, 6, 8 and 10. In mathematics, natural numbers, prime numbers, etc. can be termed as sets, since they depict a collection of numbers that exhibit certain behavior. Now, let us consider a few examples of sets which you have learnt in your previous classes. N, you have used capital N in your previous classes too. N we consider that as the set of all natural numbers. Z, the set of all integers. Q, the set of all rational numbers, and R, the set of all real numbers. Now, let us try to identify the common properties of the following sets. The first set is 2, 4, 6 and 8. The second set 1, 4, 9 and 16. And the third set is January, February, March and April. Now, let us try them one after the other. When you look at the first set given, it is 2, 4, 6 and 8. When you look at it, you will be easily identifying that these are the first 4 even numbers. So, this is the set of first 4 even numbers, which can be also called as the set of first 4 multiples of 2. Now, let us try to identify the common property of the second set. The elements of the set are 1, 4, 9 and 16. If you look at the elements carefully, we do observe that they are 1 square which is equal to 1, 2 square which is equal to 4, 3 square which is equal to 9, 4 square which is equal to 16. So, I can say this is a set of first 4 perfect squares. The third set is quite evident and easy. You all guessed it right, students. It is the set of months of a year. Let us try to write the following as sets. The first one given to us is set of first 5 cubic numbers. Before we start writing the elements of the set, let us understand what does cubic mean. Cubic means a number multiplied to itself 3 times. So, first let us take the first 5 natural numbers, which are 1, 2, 3, 4 and 5. So, their cubes would be 1 cube, which is 1 into 1 into 1, and it comes out to be 1. 2 cube, which is 2 into 2 into 2 equal to 8. 3 cube is 3 into 3 into 3, that is 27. 4 cube is 4 into 4 into 4, which comes out to be 64, and 5 cube, which is 5 into 5 into 5, and the answer is 125. Therefore, the elements of the set A are 1, 8, 27, 64 and 125. The second one is set of all factors of 20. Now, what are the factors of 20? Factors of 20, which means numbers which divide 20 exactly, that is leaving the remainder as 0. Now, let us see which numbers can be considered as factors. 1 into 20 comes up to be 20, 2 into 10 comes out to be 20, 4 5s are 20, 5 4s are 20, 10 2s are 20 and 20 into 1. So, 1, 2, 4, 5, 10 and 20 can be considered as factors of 20. So, the elements of the set we need are 1, 2, 4, 5, 10 and 20. Now, can we consider all the collections as sets? Terms like best, good, intelligent, smart, beautiful, handsome, pretty are subjective. Subjective means they depend on individual. So, such collections cannot be called sets as they are not well defined. Let us try and decide if the following are sets or not. 11 best players of the world, top 10 good books of India. Now, coming to the 11 best players of the world, best players of the world cannot be generalized. A person may consider Sachin Tendulkar as a best player of cricket, but another one might feel MS Dhoni is the best player. So, best player is something very individual. So, it cannot be considered as a set. Similarly, top 10 good books of India, which means a book considering it to be a good or not good is completely individual perspective. So, this also cannot be considered as a set. So, this is also not a set. Set given to us, it is given all the even numbers, and the fourth one comes out to be first 5 odd prime numbers. Now, let us look at the third one, which is the all even numbers. We know numbers are uncountable and therefore the even numbers are also uncountable. So, all the even numbers could be 2, 4, 6, 8 and so on, which means the set which is asked to us is unlimited, or we can call it as an infinite set. Now, first 5 odd prime numbers. We know what are the first 5 odd prime numbers, which are 3, 5, 7, 11 and 13. This is a limited number of elements in the set. So, this is a finite set. Now, looking at the elements, you might be quizzing what is the common property existing among them. Now, if we take now 1 as we can see that it is an element of A, I can say 1 belongs to A. And how do I write it as symbolically? I can write 1 belonging to A as 1 belongs to A. The symbol which is exhibited there is a Greek letter epsilon, which is used for the words belongs to or is an element of. Epsilon, the symbol may be familiar to you as English alphabet E, but it is not so. It looks similar to E, but it is not English alphabet E. Now, let us consider the same example A 1, 8, 27, 64 and 125. If I ask you, does 9 belong to this set A? You will say 9 is not a part of set A. That is true. 9 does not belong to A. And how do we show it? Symbolically, 9 is not belonging to A. We observe that the belongs to symbol is being struck off with a slanting line. So, the symbol epsilon, when it is struck off with a slanting line, stands for does not belong to, also for is not an element of. Now, let us consider a few sets and see if elements are a part of the sets or not, and we will be able to identify if the elements asked are a part of the given set. Now, the first one is in between 0 and A. What do you observe, children? 0 is a part of A. I use the symbol epsilon. Now, we have to compare between 3 and C. When you look at C, the elements of C are P, Q and R. So, if I have to say about 3 and C, 3 is not belonging to C. So, I use the symbol does not belong to. Now, moving on to the third one, which is in between 4 and B. In B, what are the elements of B? 3, 5 and 7. We do not find 4 here. So, what are we going to write here? 4 and B. I use the symbol does not belongs to. Now, coming to 8 and A, we observe that A has 0, 2, 4 and 6. Is 8 a part of the set? No. So, we will be using the symbol does not belongs to. And the last one is a comparison between P and C. Is P a part of set C? When you look at the elements of C, we observe the elements are P, Q and R. So, P will be belonging to C. Okay, children, you have learnt how to write symbolically belongs to and does not belong to between the elements and the respective sets. Now, let us consider a set A with the elements A, E, I, O, U. That is right. A is a set of vowels of English alphabet. Now, B 2, 4, 6, 8, 10, which is a set of first 5 even numbers. What have you observed there? We have written the elements of the sets as a list, which means we are listing the elements of the set. So, elements of both sets are written in the form of a list. This is one way of representing a set. Let us see in how many ways a set can be represented. A set can be represented in 2 ways, that is row roster form or list form and set builder form. There are two ways of representing a set, roster form or list form and set builder form. So, first let us know how to write a set in roster form. In roster form, all the elements of set are listed. The elements are being separated by commas and are enclosed within braces. For an example, let us take A, which is a set of first 10 natural numbers, and if I have to write it in roster form, I write A as a set 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 as its elements. Now, let us try to write the following sets in roster form. B is the set of all months in a year with exactly 30 days. We know what are the months with exactly 30 days. So, the elements of the set B are April, June, September, November. Now, let us take another example. A, which is a set of all factors of 12. Now, again factors, which means numbers which divide 12 exactly, leaving a remainder 0. So, the elements of A are 1, 2, 3, 4, 6 and 12. Now, let us learn to write a set in set builder form. In set builder form, all the elements of a set follow a common rule that defines and depicts the common property of the elements. This property may not be possessed by the element outside the set. The rule which is followed by the element in that particular set may not be observed by the element outside the set. Let us consider an example A with the elements 3, 6, 9, 12, 15 and 18. Then when we have to write the set in set builder form, I have to write it as A, the set of all x such that x is a multiple of 3 and x is less than 20. If you observe, students, you can see the braces tell you that this is the set of all x, and this symbol stands for such that, and what is the rule of x which is being followed here? X is a multiple of 3 and x should be less than 20. So, we are considering the multiples of 3 which are less than 20. That is what you have observed in the elements of A. Now, let us consider a few more examples. Set of natural numbers n, which is the set of x such that x is a natural number, and set of rational numbers q, set of x such that x is equal to p by q, where p and q belongs to the set integers and q is not equal to 0. Now, let us learn how to write the sets from one form to another, that is converting the sets from roster form to set builder form and set builder form to roster form. Let us take an example. A consisting of elements -2, -1, 0, 1 and 2. I can write this in two ways in the same set builder form, where in the first way I can write it as A consisting of the set x such that x belongs to integers and x is greater than -3 but less than 3. If you observe, children, I have used the symbol only less than in both the cases. X is greater than -3 but x is less than +3. Or in the second way, where I have written it as A is the set of x such that x belongs to integers but x is greater than or equal to -2 but less than or equal to +2. I have used here lesser than or equal to symbol and here only less than symbol, which means I can write from roster form to set builder form in two ways. Now, let us see how we can convert from roster form to set builder form, taking another example. If I have a set B with the elements 1 by 2, 1 by 3, 1 by 4 and 1 by 5, you observe the elements, in all the elements the numerator is the same, which is 1. only the denominators have been seem to be different. The denominators are 2, 3, 4 and 5. So, our set builder form of this set would be B set of all x such that x is equal to 1 by n, where n is belonging to natural number set and n is greater than 1 but less than 6. If I have to convert from set builder form to roster form, that is, I am given a set C of all x such that x is equal to 3n and n is belonging to integers and n is greater than minus 4 but less than 4. Understand the property here, children. X should be a multiple of 3, where n we are considering integers and n are taken in between minus 4 and plus 4. So, if I have to write this set builder form to roster form, I can write it as C is equal to minus 9, minus 6, minus 3, 0, 3, 6, 9. Let us take an example B, which is a set of all x such that x is a prime number which is a divisor of 60. If you understand, the elements of the set B should be prime numbers and also should be the divisors of 60. So, let us see what are the divisors of 60, which means the numbers which divide 60 exactly. They are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30 and 60. Why are these called as divisors? Because 1 into 60 gives me 60, 2 into 30 is 60, 3 into 20, 4 into 15, 5 into 12, 6 into 15 and 10 into 6, 12 into 5, 15 into 4, 20 into 3, 30 into 2 and 60 into 1. Among them, we need only the prime numbers which are the divisors of 60. So, we want only 2, 3 and 5. The rest are not primes. So, the elements of B are 2, 3 and 5. Now, let us take another example where a set E is the set of all x such that x is an alphabet in the word better. We are given the word better and we have to write this in list form. So, the elements of E would be B, E, T, R. If you have observed, I have not repeated T and E when I am writing it in roster form. So, elements are not repeated when we are writing in roster form. Now, let us take an example of a set B which consists of the elements 5, 25, 125 and 625. If you observe the elements, how can we write it in the set builder form? I will write it as B is the set of all x such that x is equal to 5 power n, where n is greater than or equal to 1 but less than or equal to 4. So, in the place of n, if we write 1, 5 power 1 we get 5. If we write 2, 5 power 2 we get 25. If we take 3, 5 power 3 we get 125 and 5 power 4 is 625, where n is a natural number. Now, let us take another example C consisting of x, where x is a 2-digit natural number such that the sum of its digits is 8. So, you are asked to write the elements of the set C such that the elements when you are taking, they should be 2-digited, and when you add up the 2 digits, the sum should be 8. Now, let us see what are the elements of it. So, I can write the elements of this set as 1, 7, 17, 2, 6, 26, 3, 5, 35, 4, 4, 44, 5, 3, 53, 6, 2, 62, 7, 1, 71, 8, 0, 80. 1 plus 7 gives me 8, 2 plus 6 gives me 8, 3 plus 5 gives me 8 and 4 plus 4 is 8, 5 plus 3 is 8, 6 plus 2 is 8, 7 plus 1 is 8 and 8 plus 0 is 8. We have observed that the elements satisfy the condition being of 2-digited and at the same time adding up the digits comes out to be the sum as 8. Now, okay children, we have learnt the concept of sets. Let us have a quick recap of all the concepts we have learned today. Now look at the first one. A well-defined collection of objects is called a set. So what do we call a well-defined collection of objects? We call it as a set. A set is denoted by a capital letter. So we use a capital letter to denote a set. Now objects of a set are called elements. So what do we call the objects of a set? We call them as elements. All the elements of a set have a common property among themselves, and a set can be represented in either roster form or set builder form. Okay children, this is a evaluation for you of what all you learnt today. Now try them for yourself and please refer your textbook wherever you find it difficult. Now look at the questions. The first one is, look at the following and decide if they are sets or not. You have to say whether the following are sets or not. Ganga, Yamuna, Brahmaputra, Kaveri. The second one is 10, 100, 1000, 10,000. The third one is all the intelligent boys in the class. The fourth one is multiples of 2. Now the second one, convert the following into set builder form. 5, 10, 15, 20, 25. The second one is -3, -2, -1, 0, 1, 2, 3 and so on. Now the third bit is write the following in roster form. I am giving you in set builder form and you have to write them in roster form. Set of x such that x is a day of the week, and the second one is set of all x such that x is equal to n, where n belongs to natural numbers and n should be less than 10. For better understanding of the concepts, solve the worksheets. Please visit the official website of SCERT for worksheets. Thank you children. Happy learning.